population means. Come with me. All right, so we have hypothesis test for means. So we're going to use X bar, S, and N to test claims about mu, population means. So claims about mu, the distribution that we use is the t distribution. We've used it before. We used it in 7.2 for constructing confidence intervals for population means. We have a degree of freedom, n-1. My calculator is going to be able to take care of almost all of this for me in terms of the heavy-duty number crunching. So let me go ahead and list the tools that we will use in this section. We will use the t-test tool. That's under the stat command over under test on the far right. You'll see where it is in just a moment. And we'll use that with the p-value method only. So we've looked at some traditional method examples, and I'm now ready to focus exclusively on the p-value approach. I can use summary data, X bar, S, or N, or raw data in a list. Now, there are a couple of requirements for our hypothesis test to hold water and to be robust. The requirements are that we have a simple random sample. A random sample is really good enough. A simple random sample really ensures we have the appropriate level of randomness. In addition to that, we need either or one or both of the following. We need n greater than 30, or the population needs to be approximately normal over the variable of interest in the problem. So let me stress that we'll use the t-test tool with the p-value approach only. I can take my data as summary data or as raw data, and we'll see examples of both. We do have a requirement or two that needs to be met, and I'll be checking those before we conduct any test. The calculator doesn't know any better. The statistician hopefully does. All right, we got a claim. The claim is that students spend more than 3 hours per day online. We're going to use the random sample to test the claim at the 10% level of significance. We've got some sample data. We have an X bar, an S, and an N. So let me go ahead and identify the requirements. We've got a simple random sample. That's important. And I've got a sample size greater than 30. So those two requirements there indicate that we've met the requirement for constructing or conducting a test of hypothesis. So let's take a look at the claim. Students spend more than 3 hours online per day. This is a claim about a mean. So the claim here is the mean is greater than 3 hours. What do I not see in the mean statement here? I don't see equality. That tells me that my statement here has a destiny. And that destiny is to be the alternative hypothesis. So we've got the random sample requirement met. We've got the n greater than 30 requirement met. We've identified the claim. What about alpha, our level of significance? A 10% level of significance means that we've got an alpha of 0.10. That's the 10%. All right, we're now ready to actually conduct the test. It's going to be a p-value test. We'll use our calculator. So, translation. The mean is equal to 3 hours. That was the claim. Mu greater than 3 hours. That is the claim that appears in my statement. So my initial claim is the alternative hypothesis. It may or may not hold water. We'll have to see. All right, I'm now ready to go ahead and find the p-value. This is where the calculator does its hard work. So let's see. Right there. Under test, I'll use t-test. I have summary statistics. My claim was a mean of 3 hours. My data says I have 3.4 for my sample mean, 2.5 for my sample standard deviation, and a sample size of 37. I have a right tail test. How do I know it's a right tail test? Remember, the test comes from the alternative hypothesis. If you get that wrong, you get this wrong, everything's wrong. So there we go. I've got the correct result there for the test. I can now ask my calculator to go ahead and find. And this is what I'm after, the p-value right there. Technically, it should be an uppercase P. My calculator can't do that. Shame on you, Mr. Calculator. But I do it right here, capital P. And I got a p-value of 116. 3 significant digits. It's a probability after all. All right, so that's the value I must compare with alpha. If this is bigger than alpha, I'm going to keep the null. Less than or equal, I'll go with the alternative. 0.116 is greater than the 0.10. So we fail to reject the null hypothesis. What does that mean at the end of the day? At the end of the day, we're going to go ahead and keep the null hypothesis. Why? It was a fail to reject. If we were plotting a test statistic, it would not fall in the rejection region. So I must now address the initial claim. The initial claim was that the mean was greater than 3 hours. So data do not support the mean being greater than 3 hours per week at the 0.10 level of significance. 1, 2, 3, 4, 5. The 5 steps for a stat test for a mean using the p-value method. I said we could use raw data. I have another example using raw data. So the mean number of units per semester attempted is 8.5. We have a random sample of students, and we're going to test the claim at the alpha equals 0.05 level. We're going to assume that the population is normally distributed over attempted units. So we have a claim about the mean number of units. The mean number of units per semester attempted by students is 8.5. The statement here contains equality. This is my null hypothesis. Now, I've got a random sample. And even though the sample is rather small, I am told that it is normally distributed over attempted units. So we have a random sample, and we have a population that is approximately normal over the variable in question. The only other thing I might need is my alpha. That's the 0.05. When I get a p-value I'll compare it to that value there. So my level of significance, 0.05. I like to be precise. I'll include the units, which are units. The flip side of being equal is to be different than or not equal. I have a claim that is the null hypothesis, and I've got the two-tail test here. So the data here will need to live in a list somewhere. And on my calculator, I placed the data in list 1. So my data lives in list 1. I'll select the t-test. See, this time I've got raw data. It will now ask me for a mean, 8.5. I pull that from the null hypothesis. My data lives in list 1. Your data may live in a different neighborhood. Frequency should be set at 1. And I've got to change the tail of the test. The null hypothesis, the alternative hypothesis is the two-tailed test. I can now hit calculate, and I'll take a look at the p-value. P-value 0.0349. So 0.0349, 0.05. My p-value is less than my alpha. So we will reject the null hypothesis. Now remember, that means you're going to go ahead and keep the alternative. So do be aware of that. If you're going to reject the null hypothesis, that means you keep the alternative. That's this guy here. So it was not the initial claim. So the final step is to address that initial claim. Data do not support mu equals 8.5 units per semester at alpha equals 0.05. I will note that it does at alpha equals 0.10. That wasn't the question, but it's good to know that it's the alpha that we bring to the party. It's what we decide to use. That's not a math number there, that's a people number. Thank you and goodbye.